That seems it. Yeah, good. Excellent. Sorry, microphone wasn't switched on properly. So over here I have my fork of Ruby with the thread selector implementation. It's super lightweight, and it basically just the way that it works is you create a thread, you create a selector which does non-blocking I/O, and then you assign that selector to the current thread, and then everything in this thread becomes asynchronous, sort of. In this test, we make a pipe, we set the input and output ends to be non-blocking. Eric did a great effort to try and make this the default, but on Windows it was just impossible, I think. So we'll probably have to revisit this. Maybe this is the case where on platforms where it can work, it becomes the default. I'm not quite sure about that yet. And then over here we create two fibers inside the thread, and the first fiber basically calls, write and close, and then the other fiber calls it's getting each character in an enumerator, and then it's reading it out one character at a time for some reason. I guess I felt like I should make the spec a little bit more exciting. And then at the end we just call selector.run, which will resume those fibers as the events, such as it's writable, it's readable, and so on. So I only ever implemented this proof of concept selector, and it's not particularly efficient. It uses io.select, and it uses hash table and for the wait readable and writable, and then it has this kind of next timeout function. It's like a really crappy implementation of how long should I sleep until the next thing that I'm interested in is ready to go. So basically the three entry points here are wait readable given a file descriptor, wait writable given a file descriptor, and wait sleep given a duration. And so those operations basically come into the selector. They essentially call fiber.yield or fiber.transfer, some way of yielding control back to the scheduler, and then when the operation can continue, the scheduler will pick up and resume that fiber, and it will keep on going. So it's, I guess in a way, like it's kind of lightweight threading or green threading, but it's sort of not, because it's tied to one thread, which I think ultimately is a benefit for the majority of users because you don't want to deal with thread safety issues. So this selector is just a proof of concept, and now it is time to make it possible for Async to export its reactor in such a way that it can tie into those events, and then any Ruby code that uses Ruby's I/O, which calls wait readable or wait writable, will come through to the async reactor and then be scheduled according with all the other async stuff that's going on. So that's kind of exciting. So let's start off. So I just made this file here. It's fully experimental, so this won't be in a official release, I don't think. But maybe just a testing branch. So the three events we need to handle, that one, so we're going to create this scheduler, and the scheduler is going to be attached to a reactor. And so the reactor is the event loop, which is going to help us deal with these events. So the reactor provides a few primitives for dealing with I/O. This is a wrapper, and the wrapper wraps around a Ruby I/O in a given reactor, if you know what it is. Otherwise, it will try and figure it out. And then it has these wait readable and wait writable functions, and so we can probably just patch that in. Well, this is theoretical until we show it working, I guess. So let's try that. Oh, and there's another tricky thing, which is, and this is not going to be particularly efficient. We have to turn the file descriptor back into an I/O, I believe, which is kind of painful, and some of these like layering violations can probably, they don't affect user code, but they're just really good opportunities to make things better. Let me just grab some coffee. I'm not sure how crazy it is, but I started putting aniseed in my coffee. It's really good. Some people don't like it though. That's okay. Okay, so I think iOS by default will auto close. What is that actually? Okay, so I wonder if there's like, does that work? Oh my goodness, it works. Okay, perfect. For file descriptor, auto close false. Wrapper equals wrapper.new IO. Now, the reason for this wrapper is because when I first built Async, NIO4R, the underlying wrapper around poll, epoll, select, whatever, all the the OS primitives, it works best if you cache the monitor which is associated with that file descriptor. So what that means is the operating system, when you insert something into the epoll, it will give you back a handle which you need to hold on to. And so wrapper kind of helps that process to be more efficient because the wrapper encapsulates that. Now, interestingly enough, with Linux's new IO ring, so new API for doing non-system call IO, it actually doesn't matter anymore because you register the event into an event queue and then you forget about it until something happens, until it's done. So this actually is just an inefficiency around the design of the existing operating system APIs, and potentially there's a chance that it gets a lot more efficient, i.e. one less memory allocation, one less syscall or whatever. So that's really exciting. So I like the fact that sometimes there's these things you can improve without the user code changing. To me, that's like really great. Anyway, we're just going to basically go wrapper.wait readable, and we don't have any timeout, but let's just pass it through just in case that ever gets added. Let's put this in a private method. Private. And I guess just based on the current design, maybe I should cache these wrappers, like a hash table from file descriptor to wrapper. I don't know. It might be more efficient. The other thing is, if you aren't careful, you can't insert the same file descriptor into the run loop multiple times. And so that wrapper actually has logic to try and catch those situations. So like in here, if you call wait writable, and there's already someone waiting to become writable, it raises a wait error. Same for readable, and same for any. The thing is, you can't have two tasks reading from the same underlying socket. It's just nonsensical in most cases. I think in the situation that you have UDP and you're pulling out discrete packets, maybe it's possible, but certainly in that case with an asynchronous run loop, there's no performance benefit. Maybe if you have like 8 threads all reading from the same UDP socket, it makes sense. But that's an entirely different situation. So, okay. From we'll wait readable, ensure. I love that new operator. Okay, now wait sleep is actually pretty straightforward. So somewhere down here we have this method. I think that just will work as is. And I think that could actually be the entire implementation that's required, which is surprising. Right, so let's have a go at taking that test. Where was it? Let's see if we can make that work. Right. Hold on. How do you make RBM use a different Ruby version? Or I could just directly point it at it, maybe. Okay, this seems to be working. Okay. Actually, maybe I can just use thread.current. That probably should work. Okay, so we're going to start off with the async task, and what we want to do is we want to set up the thread. And I might change this to be scheduler because I think as we start going down this path of making more and more Ruby operations asynchronous, it's not just going to be IO selected, but it's going to be like DNS and file system operations and a whole host of other stuff. So we're going to make a scheduler, bind it to the current task reactor, and then we're going to set that, and I guess, like, just for completeness sake, and all of this probably go inside a function. The user doesn't care about how any of this stuff works. We're just doing this because it's the first prototype. Right, let's get that stuff. Now, instead of file, we're just going to use async. And because we're already operating asynchronous context, we can just do this because we just want to wait till it's finished reading anyway. So let's see, before I pull the trigger, does any of this make sense? They'll be exciting if it works. Cannot require, okay, yeah. I'm so used to RVM that I just always, someone should just make that an alias. It would be like make my life so much easier. Right, so we'll install all the dependencies into the 2.8.0 dev that I just built. It's still running tests. So in other news, we released Rack 2.1.0, which is an awesome achievement because it was like 3 years old, like 300 or more commits, and it's broken a ton of crap, which is awesome. So don't upgrade unless you have like a good test suite. But it's good because it's the first official release to support Falcon in its like list of web servers to choose by default. And it's also more efficient by default because it doesn't try and double buffer every middleware that uses rack response. So it's actually going to be pretty sweet to see that in production. And I think we'll have Rack 2.2 coming out like pretty soon. And that will have today, like I think I merged about 20 or 25-ish pull requests into Rack. Just like small stuff, little bugs, other little bits and pieces. And so hopefully there'll be the last 2.0, 2.x release, and then we'll be able to start working on Rack 3, which will just, there'll be a bit of, what is it, slash and burn, getting rid of some old code that probably should have gone a long time ago, but anyway. Okay, so we have everything in there. Hopefully this doesn't like blow up again. Undefined method, gotta require this extra bit. End of block, okay, yeah. I wasn't sure if that was going to be a problem. So we have these new methods which I've been playing around with. It's actually something I implemented very recently called enter blocking region. And what these do is they capture when the Ruby VM invokes something which is literally blocking the VM to the point where the current thread releases the GVL. So like an example of that would be a low-level read call, or a low-level write call, or get host by name, or get address info, or just like any kind of blocking call that is called by the Ruby VM is wrapped by this method called noGVL. That is the method which releases the GVL from the current thread so another Ruby thread can run, and it executes in the presumption that the function pointer it's been provided is going to execute something blocking literally from the operating system point of view. So I added a little wrapper around that so we can capture when you enter these blocking regions and when you exit those blocking regions. And the point being that we can measure how long a particular asynchronous task is actually blocking for, because blocking is while blocking is occurring all the way down to your like L1 and L2 cache on the CPU, there are definitely high-level points of blocking, like say DNS lookup, that potentially could take seconds or longer or indefinitely. like imagine if you have a file system mounted through NFS and your network is down, right? And you try and read from a file, it's just going to probably take forever. So the point being, we can record that and report on it. So let's just do that, see, because it's kind of a cool thing. So we get the operation that was blocking by going caller, I think it's -2, like second. Hold on, I have a partial implementation in. I think I did sort of do, yeah. Yeah, it is caller -2. Okay, right. Actually, instead of using time, let's use clock. And what is it? Clock.now. Okay, that's interesting. Require. Yes, nothing works. Am I running the right file? No. This one. Unfile a message from me. Okay, so something happened. Maybe not what we wanted. Okay, let's have a look at what's going on. Did it do that bit? Yes, it did. Did it do that bit? Yes, it did. Okay, it got some letters. That's encouraging. And then it called i.close. Oh, I'm an idiot. It was working all along. We just didn't print out the message. There we go. I always get so confused. This is a shell runner that I made for Adam. And it really needs to print out like script finished X status 0. I don't know. Something like tells you that it's done. You just like run, okay, did it finish? Oh, it's awesome. It worked perfectly. So this is a scheduler. It's like 63 lines of code with that stuff. Let's have a bit of a look at what's going on here, because this is kind of cool. I don't know if I can call binding.irb in here. I think I might blow up the interpreter. Then we'll see what happens. Yeah, something not that happy. It's executing inside the code that releases the GVL, so I'm not surprised it doesn't work with IRB. Okay, let's just have a look at what call actually is. Can we nice print out like exactly what operation was going on? Why is it still self-destructing? What operations can I do in there? I don't know. So it says it's blocking for 0.0 seconds on line 22 of pipe.rb, which is that one, which is interesting. That becomes non-blocking implicitly, but that one is still a blocking operation, which is actually pretty fascinating because the close operation in your operating system, I would be surprised if that actually blocks for any real length of time. But I guess just by definition they have to. So what is -1? So maybe out of curiosity, let's try using sleep as well. Sounds like there's a party going on behind me. Oh yeah, there is. Hello world. Okay, messages. C. I hate abbreviations. Okay. And what is I and what is O? I could be anything. I've read code where I'm not even sure if the author knows what the abbreviation means because there's multiple different interpretations. The code gets so complicated that you're not even sure. Like there's multiple words in the code, the full length words like concepts, and then you have an abbreviation which could be like any of them, and maybe it just gets used for both of them. Like maybe that's the point. You make the variable name is short enough so that it can be used for both kinds of things without ambiguity. With ambiguity, I don't know. It is just so much better to encourage people to use full words, especially if you're a foreign speaker. I once tried to read code in French and it was crazy. Okay, so what I want to do over here is I want to call sleep, and over here, rather than accumulating it, I just want to so this will truly show the non-blocking nature of what's going on. What have I missed? Okay, for some reason the enumerator is... Let's just go to the enumerator. Wait for single file descriptor. Okay, we didn't implement that one. So Ruby actually has, I lied, Ruby actually has 3 methods for non-blocking IO, and this is the third one, wait for single file descriptor. You think they'll just do them all together? I don't know. Super confusing. But anyway, who cares? So, oh, and the events field is not documented. You have to just assume that that means readable, and yeah, it's confusing. So what this maps to probably the simplest implementation of this is just wait any. Because if it's non-blocking, it is possible the operating system gets spurious wake-ups, and so we're just gonna we're gonna piggyback off that. So we don't care. They might have been waiting for readable events, and we're gonna say, oh, it's writable. I guess it's slightly less efficient, but I don't care at this point. So. Stream closed in another thread. Which one? Okay, see what's going on. We might not want to call that because it's closing the underlying file descriptor, but we might need to I think what we need to do instead is this disconnects the wrapper from the reactor. I don't know if we can do that. What am I doing? Okay. There we go. That looks pretty good to me. So there you have it. A scheduler which piggybacks off the async reactor. It implements the interface required by the Ruby interpreter, the interface that I put together, or ages ago, I guess. And those are the methods that the interface is required. That means that when you have native I/O and you set it to be non-blocking, it will integrate seamlessly with async. So if you use NetHTTP or NetSSH or basically anything which correctly uses the Ruby interpreter's I/O primitives and wait readable, wait writable, and so on, it will be transparently non-blocking, which I think is pretty cool. And in theory, because async works with JRuby and truffle Ruby, in theory, it's possible that this still works. And we don't need to re-implement all of this stuff to have non-blocking I/O in Ruby. We can just use this gem which already exists. Or someone can take Event Machine and they can make the same scheduler but for Event Machine. And I think that's great. Yeah, I think it's awesome to have diversity in programming and in APIs, because it challenges us to make the best APIs we can possibly make. Right, well, that's all for today. Thank you for watching. I hope it was interesting. And feel free to like, subscribe, and if you want to support this work, you can sponsor me on GitHub, which would be awesome, especially if you're a business. That would be fantastic, because it just it means I have to do less commercial work, and I can do more of this stuff. So, excellent.